creating a neural network to play the game Connect 4 with a genetic algorithm. In Connect 4, players take turns dropping pieces into a vertical board. The first to get 4 in a row wins. A neural network is a type of AI modeled after an organic brain which consists of interconnected neurons. Neural network AlphaGo Zero became the world's best Go player using unsupervised learning. My project explores another type of unsupervised learning which is unproven and relatively unused, called a genetic algorithm. Each generation of the genetic algorithm is created by mutating a seed. Members of the generation compete at a task and are rewarded based on the outcome. The highest scoring member of each generation becomes the seed of the next generation. The amount by which the seed is mutated to create each generation decreases from 1 to a value I inputted by the user. I created a logic-based human simulator to act as a benchmark against which I can measure each subsequent generation. The seed of each 500th generation played against fake human, and the resulting score of the seed was recorded over 100,000 generations. I ran 4 separate genetic algorithms with different values for I and graphed the results. Every trend line exhibited step-like behavior. Interestingly, the trends stepped in order from least to greatest values for I. Then I wondered, what would happen if I ranked the neural networks in a generation solely by their competency against fake human? I graphed the results and noticed the same stepping pattern. Additionally, identical tests run for 10 times as long yielded the same pattern. I won against the resultant neural networks from all of my genetic algorithms, causing me to deem an empirical study with the general population unnecessary. However, one resultant neural network from my original genetic algorithm setup exhibited blocking abilities, and I recorded all positive trend lines against my benchmark. Here are some things I took away from my data. Because a genetic algorithm is a random process, I assumed longer stretches of time would lead to a higher likelihood of finding a strategy and would give better results. However, when I ran my test for 10 times as long, the graphs were nearly identical. Trend lines with a sharper taper stepped up first, supporting the first point. This is good news for genetic algorithms, as it may lead to a shorter than expected length of time necessary to produce results. Next, I will test how fast of a taper can be used to produce equivalent results. Over the course of my project, I have realized that flattening the Connect board to input it into my neural network is a mistake. I will try using 3-dimensional neural networks called convolutional neural networks, which take a 2-dimensional input, and see if I get any improvement in my results.